Hello, I'm Don Cross, the developer of the Sapphire plugin for VCV Rack. Today I'm going to show you a couple of new Sapphire modules I've been working on. The first one is called Frolic. Frolic is a chaotic oscillator that gives you three independent but related control voltages. So Frolic is good for situations where you want signals that are somewhere on the spectrum between completely predictable and completely random. Let's dive in and see how it works. I'll use Frolic to control some CV inputs on Sapphire Elastica, but of course you can use Frolic for any module that has CV inputs. To save some time, I created a fun preset for Elastica, and I'll load that one. And we will wire up the audio. We're starting to get some sound already. And I'm going to connect Frolic to some CV inputs. As you can see, the output voltages here on Frolic are called X, Y, and Z. Let's wire up the X voltage to the spring stiffness parameter on Elastica. And I'll send the Y voltage over to the spring span control on Elastica. And finally, we'll take the Z output from Frolic and hook it up to the magnetic field strength, the curl input. We'll listen for a little bit here. Yeah, this is fun. If it's not quite clear to you what Frolic is doing, you're not alone. I was in the same position. I wanted to understand the dynamics of the voltage better myself, so I started out using the VCV scope module, and I was graphing the X voltage, versus the Y voltage on a 2D plot, and then X versus Z and Y versus Z, and that helped. But it's not ideal because we're trying to visualize a 3D curve, but all we have is a 2D oscilloscope. So I started thinking, what if I had a 3D oscilloscope? So I decided to create a module that can record and display 3 voltage signals in a 3D space. And the result is called Tricorder. So we'll go ahead and add that in. So you have the Tricorder module. Tricorder is designed as an expander module for Frolic. So all you need to do is slide it over and attach it to the right side of Frolic like this. We can see there's a 3D curve forming here representing the X, Y, and Z voltages coming out of Frolic and being plotted on a Cartesian three-dimensional space. If I hover the mouse over the display area, you'll see some commands up here. The double chevron symbols, like this one and this one and this one and this one, allow you to rotate in different directions. So for example, I can change the rotation to be this direction, or I can go the other way. Go left or right. Now, that's nice, but you might want more manual control. If you do, you can click somewhere in the middle of the display and start to drag the mouse around. You can manually change the latitude and longitude angles. Get a little bit of insight into what this curve looks like from different angles. So really this gives you much better visualization of what's happening. with this Frolic module. If you want to rotate again, you can click the rotation button and it'll start rotating again, because anytime you click and drag, it stops the rotation. You also have these plus and minus buttons here. They let you zoom in, zoom out. If you get some wacky state, like you can't tell what's happening, like I'm lost, help me, you always have this home button up here that resets the orientation and zoom to the initial state. So it helps you get back to where you know where you are. And finally, in the, I'll start it rotating again. In the lower left corner, you have this XYZ button. This toggles whether you show the coordinate axes or not. So if you find them distracting, you can turn them off. If you like to know which way X, Y, and Z are, you can turn it back on. So now that we can both see and hear what Frolic is doing, let's go back and play with its controls. Frolic is pretty simple to operate because it has only two controls, the speed knob and the chaos knob. And also I have CV input and attenuverters, so you can automate controlling these things. Today I'm just going to show you manual control because you'll get the idea. The speed knob allows a very wide range of oscillation speeds. The scale goes from the default of 0 all the way down to -7. So -7 is very slow. You can see what I mean. You can gradually come back up to the default speed again. And it goes all the way up to a +7. So we'll try that out. So we're at 3.4 or so right now. Let's keep going. You can get pretty fast. You can see this signal is changing quite quickly. Let's take it back down to the default, 0. On this speed knob, every unit that you increase, like if I go from 0 to 1, doubles the speed. So now we're going twice as fast as the default speed. So since it goes from 0 down to -7, that 2 to the 7th power is 128. We can make the speed 128 times slower, or 128 times faster. So that's a range of about 16,000 in the speed control. Okay. The other control we have is the chaos adjustment knob. Probably what's best is, let me speed this up a little bit so we can more quickly see what the chaos knob is doing. So you can see that at the default of 0, this signal is changing. It's doing kind of a double loop, and sometimes it'll orbit one of the two lobes of the butterfly wings for a while. So it's kind of halfway between random and predictable. If I go all the way down to -1, it will quickly settle into this stable pattern, this double loop. And if I start to increase the chaos knob a little bit, at some point you'll see it start to bifurcate into a double loop pattern. Still pretty orderly. As you go up to the default value, come back to where it's a little more moderate between orderly and random. And you can increase this all the way up to a maximum value of 1, where it gets a little more eccentric and it can start to spiral in and out and dance around. And so you get the idea. This is just sort of controlling what kind of behavior you get. Let's turn it down a bit slower. I'm recording this on October 20th, 2023. Frolic and Tricorder are nearing completion, and I'm planning on submitting them to VCV Rack for approval in the next week if everything goes as planned. And so they should be available by November the 1st, I'm hoping. It'll be around the first week of November. One more thing before I sign off. As of today, as I'm recording this, Tricorder only works with Frolic as an expander module. I realize that people might want to use Tricorder with other 3D input signals that they create. So I'm planning on creating another module that attaches to the left side of Tricorder that has 3 input ports. So this new module will let you feed in any 3 signals you want into Tricorder and graph them. So that's not ready yet. I can't demo it, but it will be a part of my initial release for this stuff. So that's it for today's demo. Thanks for dropping by and letting me show you this fun new stuff I've been working on.